Okay, welcome back to the Mole Vodcast number 3. Today we're going to be talking about single-step conversions. This is kind of the meat of our mole unit, so we're going to need to start off with a few absolute non-negotiables, and these need to be in your notes without fail. I need to be able to see these to check these off that you have these, because you're going to need to memorize them. And I know that it's difficult to hear that, and it's difficult for a lot of you guys to actually commit things to memory. You need to practice. This is a good example, a good time for you to practice on this. These are 3 mole equalities that you absolutely must know. These will not be provided for you. They're numbers that you're just going to have to know. The first, of course, is the one that we've talked about in Mole Vodcast number 1, which is 1 mole equals 6.02 times 10 to the 23 particles. Okay. At this point, you should be able to tell me exactly the number of a mole. 6.02 times 10 to the 23rd. Okay. The next is what we covered in Mole Vodcast number 2, which was the molar mass in grams. So 1 mole equals the molar mass in grams. And for elements, that's really easy. You just go to the periodic table. And for molecules, of course, you must calculate this based on the molar mass from the periodic table of your individual elements. Okay. The last one, and this is the one that you're really just going to have to memorize, is 1 mole is 22.4 liters molar volume. Now, there are some stipulations on this because it's not always 22.4 liters, but it is if it is a gas, only if it's a gas, at what we call STP. Now, for those of you who actually have completed your vocabulary at this point, you know that STP stands for standard temperature and pressure. Okay, standard temperature and pressure. That is 0 degrees Celsius at 1 atmosphere of pressure. So this is 22.4 liters of a gas at standard temperature and pressure. So if we're working with a gas like oxygen gas or nitrogen gas or carbon dioxide gas, and we talk about 1 mole, that mole of gas is going to take up 22.4 liters. That's the molar volume. Okay. I would like for you to take a moment, if you have not already gotten all of these equalities down. These need to be in your notes. You need to review them. You need to have them committed to memory. We will be using these equalities to complete our dimensional analysis, to do various calculations using moles and molar mass and molar volume in the coming examples. I'm going to do 4 examples with you today. The first 2, I'm actually going to go step by step with you through the process. For the second 2, I would like for you to try working them on your own. Pause the video, work them on your own, and come back and play the rest of the video and see how you've done. This will give you an opportunity to kind of put this into practice, and then we can always come back and fix any mistakes that you might have made. Okay, so let's go ahead and get started on our first example. The first example, I'm actually going to give you which equality we're going to be using in the dimensional analysis. So for this first one, we're going to be using the 1 mole equals 6.02 times 10 to the 23rd part. Now, in the future, you won't be given this equality. You will need to have it committed to memory. And hopefully by now, you guys know that 6.02 times 10 to the 23rd is the same thing as a mole. So if you put these 2 numbers over one another, it's the same thing as having like 1 over 1. It's 2 things that are equal that can be used in a dimensional analysis type problem. So here you have how many atoms of copper are in 1.65 moles of copper. So here you're taking a question that you guys have already seen, which is how many atoms of copper are in a mole of copper, but you're tweaking it. And you're saying, okay, so if there's 6.02 times 10 to the 23rd particles of copper in 1 mole, what about 1.65? So let's take a look at how we would go about setting this up. the first thing you need to remember is that you always take the information that you are given in the problem and you put that down first. The information given in the problem goes into the dimensional analysis in the upper left-hand corner. So we put that down. We know that we have 1.65 moles of copper. Now, when we're setting up our equality to convert this number, we want to make sure that we're able to cancel out the moles of copper. We want to replace those moles of copper with a number of atoms. So our moles of copper need to go on the bottom. And we know that 1 mole of copper is equal to how many particles? Well, it's 6.02 times 10 to the 23rd. So this gives us a very simple dimensional analysis problem. We multiply across the top, 1.65 times 6.02 times 10 to the 23rd, and we divide that by 1, and it gives us 9.93 times 10 to the 23rd atoms of copper. So that is a very simple single step conversion using moles. So we have a number of moles, 1.65. We've used our equality to find out how many particles that is, and our answer is quite simple. You will note that we use the same number of significant digits in the answer here that we had in the original given value. So make sure that if you have 3 significant digits here, then you need to have 3 significant digits here, and you need to round if necessary. Okay, so for our next problem, I'm going to again give you the equality. We're going to talk about molar mass, so I'm going to give an example of using molar mass in grams. So now we're talking about moles to grams. So how much does a mole weigh? And if we recall from our Vodcast number 2, we have, for H2O, we have to keep in mind that there's more than one element there. So a mole of H2O is going to incorporate the molar mass of the hydrogen times 2 and the molar mass of the oxygen times 1, and we're going to add that together to see how much a mole of H2O weighs. So again, to set up the dimensional analysis, the first thing you need to do is put the information that you know, which is that we have 2.8 moles of H2O, and we put that in our dimensional analysis on the upper left-hand corner. So we have 2.8 moles of H2O, and then we use our conversion factor of moles to grams. So we want to put moles of H2O on the bottom, right? And we know that 1 mole of H2O is equal to how much weight? How much does 1 mole of water weigh? Well, that was discovered when we did the Vodcast number 2, when we calculated the molecular weight, or the molar mass of H2O. So if we take 2 hydrogens, okay, each one of them is 1.0079 or 1.008 grams, and then we multiply that by 2 because we have 2 hydrogens. Then we have 1 oxygen, and we multiply that by 1 because there's only one of them, and it is 15.999. And we take those 2 totals, add them together, and we get a total molar mass of water, which is 18.148 or 18.0148. Excuse me. That's grams per mole. So of course we can bring this grams, this 18.0148 grams, and we're going to bring it up here because that is equivalent to 1 mole of water. Okay, so we have our molecular mass, which you've already learned how to calculate down here. We're going to plug this into the problem right here, and this is going to give us how much 2.38 moles of water is going to weigh. We of course multiply across the top, multiply across the bottom, and we get 14.9 grams of water, which is equal to 2.38 moles. Okay. Now, for this next problem, what I do want you to do is I'm giving you the equality that we're going to be using, and I'm going to give you the problem. Now what I would like for you to do is stop the video at this point and attempt to work this problem, or at least set up this problem on your own. And if you're struggling with it, struggle with it. Give it a second. See if you can't use what we've just done in the last two examples to set up this problem. The problem is 7.83 liters of oxygen gas, and of course we're going to assume that standard temperature and pressure would contain how many moles of oxygen? Okay. I've given you again your equality there at the top. Okay, go ahead and pause the video right here and give it a chance. All right, now that you've given it a shot, we want to set it up and show you how it's done, and I want you to try to match this to your own attempts. So if we take a look, we always want to put what we know in the upper left hand corner. We know that we have 7.8 liters of oxygen, okay, and remember that oxygen gas is O2. It's that diatomic molecule. So this would become very important if we were looking at the mass of this oxygen gas. So please keep in mind that your gas is particularly oxygen gas or hydrogen gas or nitrogen gas is all going to be diatomic. So if you have your 7.83 liters of oxygen, what are we going to need to put on the bottom so that those liters of oxygen cancel out? Well, we know our liters of oxygen in 1 mole is our equality. So it's 22.4 liters of oxygen are going to be equal to 1 mole of oxygen. Okay, then that means we take 7.83, we divide by 22.4, and that will give us 0.350 moles of oxygen. Now remember, because we had 3 significant digits in our original problem, we do need to round to 3 significant digits in our answer. So instead of 0.35, we do put 0.350 moles of oxygen. Okay. This next problem, I'm going to again ask you to pause the video and set this problem up and try it on your own, and then come back to me. Okay, now with your moles of NaCl, and what we're given is the 73.48 grams of NaCl, you'll notice one that I didn't give you the equality that you needed to use. So instead of providing it for you, you should have taken a look at your equalities chart. Of course, you start with what you are given. You're given grams here in the problem. So you put 73.48 grams, setting up the beginning of your problem. 73.47, well, I apologize for this, it should be 48, but 73.47 or 48 grams of Na. Now, what you need to think about at this point, where you have your 73.47 grams of NaCl, your table salt, now you want your equality that is going to match up with the fact that you have grams but you want moles. So you're going to look at your equalities that look like grams and grams to moles, which is of course going to be your molar mass. So we need to find the molar mass of NaCl, which is easily enough done. You use your periodic table, find the molar mass of your sodium. You have 1 sodium atom and you have 1 chlorine atom. You add those two together to get your grams per mole when you're dealing with table salt. This is your 58.443 grams per mole, which you've already calculated a couple of times in your process. Once you put in that equality to 58.443 grams of NaCl to 1 mole of NaCl, that gives you your necessary dimensional analysis to get 1.257 moles of NaCl. Okay, with that information, you should be able to complete the coming work that we're going to be doing. If you have difficulties with this, please come in and see me, and I will see you in class tomorrow.